part one of how to calculate Cronbach's alpha, I showed you just essentially how this alpha function works. How it works generally, and then how you can have it reverse score your items if your items have different scoring orientations. For this second video, I'm going to show you how to calculate Cronbach's alpha if you're using a big data set, which is how it'll normally look when you're conducting social science research. So as I mentioned, in social science research, we often have a big data set with multiple variables. And before we start analyzing those variables, we want to know how they're correlated or maybe other relationships we want to look at, we need to make sure that they are reliable. Because if they're not reliable, then it's not giving us a very good indication of the traits that we're trying to measure or the perceptions that we're trying to capture or whatever it may be. So for this scale 1 that we had before, this was all just a bunch of items for one trait that we're measuring for extroversion. But what do we do when we have a data set with maybe multiple different concepts in it? Maybe we have extroversion and agreeableness and maybe some behavioral outcomes that we're interested in, number of dates or something, I don't know. So how would we calculate Cronbach's alpha if we have multiple variables in one data file? So in order to do this little exercise, we're going to have to load in our extroversion data set. So we'll make an object called extroversion. It's going to be a data frame, and we're going to load that data frame from a Excel file. We've done this before, so hopefully this is getting a little more familiar to you at this point, but then you'll find it wherever if you got it off your computer, it'll be in your downloads folder, or if you saved this file somewhere else, then just go find it in your computer. Select the file and then open it. And then here we have our data frame. And as you can see, we have these items here up at the top. Looks like extroversion 1, extroversion 2, extroversion 3, and then we have these other items over here that are capturing something different. Here's a nice little piece of code here if you want to just quickly see what you got going on with your data file. You don't necessarily have to click on it to see all of it, but you can just click head and it'll show you just the top and then some of the first couple of respondents. So this one's nice if you just want a quick glance. Okay, so we have these extroversion items, and then we have these other items which are measuring novelty-seeking behaviors. And we want to, or novelty-seeking tendency. We want to do Cronbach's alpha, so internal consistency, for extroversion and novelty-seeking separately, because they're two different things. So we don't calculate reliability for multiple concepts, right? We're going to have different measures of reliability for each different thing that we're trying to measure. If we have extroversion, that's one trait that we're looking at. It's going to have a measure of reliability for extroversion. The novelty-seeking tendency is a behavioral tendency. It's a different thing that we're trying to measure. It's going to have a different reliability estimate. So we have to separate them out in order to calculate those reliability estimates separately. So as I mentioned here, if we put in the whole data frame like we did with this scale 1 data frame from before, we're not going to get a reliability estimate for anything. Because it would just be those two different concepts together. It doesn't make any sense to do that. We need to figure out the reliability of each of them separately. So I'm going to show you two ways to do this. The first, which is one that I really like, is to make two new data frames from this original data frame. And the two data frames will contain items from one of them will just contain items from about extroversion. These will be for the extroversion items. I'll go over this in more detail in a bit here. And then the other one will have just the novelty-seeking items. Okay, so we're going to make two little mini data sets that are just items for one concept and then just the items for the other concept. So we're going to name our object. I'm going to call it ext items. And this says set it equal to, and then we use this data frame function, just like we've done before. And like we've done before, the data frame function, what follows after it, has to be a series of vectors. And those will comprise your data frame. And as I mentioned before, you can name a vector in an existing data frame using the same thing that we keep using over and over again, which is, it's essentially you name your data frame, if I can type, and then you name your variable. So this just says, I want this vector from this extroversion data frame. So look in the extroversion data frame and find the ext1 vector. That'll be our first vector. Then we'll do the same thing for the second vector and the third. So it's telling R, look in the extroversion data frame and just take this one, this vector, then that vector, and then that vector. So we're separating this data frame out. Okay, so we run it, and over here we have a new data frame that looks like it's probably correct. It's the 3 variables. It has the same amount of observations as the original parent data frame that we used. And then we click on it, and what do you know? These are the correct variables that we wanted without the ones we don't want. And again, you can do this the fast way too if you want, using this head function. Okay, great. So now all we have to do is the same thing that we did in part 1 of calculating Cronbach's alpha. We use this alpha function, and it takes a data frame, so we can put it this segmented out data frame that only has the extroversion items, and calculate Cronbach's alpha. And then we'll scroll up to find our raw alpha, and here we have it. It's 0.75. Nice. So that's an acceptable level of reliability for Cronbach's alpha. As I mentioned, it should be above 0.7 usually. That's typically the convention. Now we'll do the same thing for novelty. So we need to calculate the reliability for novelty as well. We're going to make a new data frame, a little mini segmented data frame. We're going to call it novelty underscore items. We're going to set it equal to, using the data frame function, this vector novelty1 from the extroversion data set, and then this vector novelty2 also from the extroversion data set. So I'm going to run it, and here we have it up here. Looks like it worked. Yep, just these 2 here for us, not the other one, not the extroversion ones. Another way of checking. Apparently I feel like using view today, but you can also just check using head. And then run the alpha function on this mini segmented data frame. And we scroll up and we see it's 0.78 under raw alpha. Awesomely awesome. Okay, now I'm going to show you a different way, which is a little faster and probably easier ultimately. So you can tell R to look at a series of columns in the original full data set without subsetting it. So we'll just modify our argument that comes with naming the data frame that you want to use. As you remember, when you use alpha, you have to have a data frame in it. But if we just put in extroversion, it'll have all of those 2 different concepts in it. We'll have novelty seeking and extroversion in it, which wouldn't be helpful. We're probably not going to have a very high alpha if I check. Actually, it's pretty high still. But it's measuring 2 different things, so it doesn't really make any sense to do that. So we need to tell R, essentially with this, what we're doing is look at the first column all the way to the 3rd column, and then run this alpha function on just the 1st, 2nd, and 3rd column. So that this symbol means essentially 1 through 3, right? like I have down here. This just is how is the convention for how R takes how R conveys this. So 1:3 is telling it look at 1 through 3. So look at columns 1 through 3. If we go back to our original data set, the first column is extroversion, second column is extroversion, and third column is extroversion. So we're saying look in this data set and just look at these columns. Oops. All right, now we'll run it, and we should get the same thing that we got before, 0.75. Yep, for extroversion, we got 0.75. And then we can do the same thing for the fourth and the fifth column, representing the novelty-seeking items. And we, again, should get the same thing, 0.78, yep. So I just show you those two options in case one of them makes more sense to you. I used to do everything like this, making little subsets of data, but this is actually quite a bit cleaner, quite a bit easier, keeps your objects over here a little more neat. So whatever works best for you. The key idea here is that for each different thing that you're measuring, you're going to have different reliability estimates. If you're measuring 3 different things like extroversion, novelty seeking, and agreeableness, each of those distinct things will need a different measure of Cronbach's alpha, if that is the type of reliability that you're interested in. And like I said, usually when we're working with social science data, it's going to come in a big file like this extroversion file with a bunch of people and a bunch of variables. So we have to learn how to segment it out. Okay, so with that, that is how you calculate Cronbach's alpha. If you have any questions or need any additional help, be sure to read your book and then come to me, and I'm happy to meet with you and talk things over.